Okay, so the first question is asking about a linear equation here. It's a two variable equation, so we've got some books, different types of books and so forth. I'm not going to get too far into the actual assignment, but I do want to go over a couple things with it. So first things first, as you guys are looking at the assignment, I'm going to go ahead and move my screen from seeing me to actually seeing my my work here. So as you guys can see here, you guys should see in the corner here my work. So first thing we want to do is create a equation, and that's what I've done here for part one, is create an equation for that scenario. Notice I labeled my variables A and B to represent each different type of variable. The second part was asking you guys to plug in your the answer. So with 10 board books and 5 soft cover books, does that fit? And the answer in this case is no. I plugged in 10 and 5 into each one. The third part is the graphing part, and this is why it's really important for you guys to complete this on a paper, a notebook paper. Make this a little bigger so you guys can see it, so that I can see that you know how to graph these. Now, that being said, I want to show you guys a tool. So I'm going to share my screen with you guys and show you how to use a tool called Desmos. So Desmos is super helpful, especially with graphing. So let me go ahead and share my tab with Desmos. So hopefully you guys can see the web page. All you have to do is type in DESMOS into your Google browser and it'll show up. And then once you get in here, this is a pretty cool tool to use. So I'm going to show you how to graph this particular problem. So if I plug in 1.5 and then I use X instead of A, plus 0.5 Y. So that's my second variable. And then I set that equal to 20. And you can use your keyboard, or there is a show keyboard and you can plug in values using this keyboard as well. And what you're going to find is that Desmos, so let me enter that in, and let's take a look here. And you can zoom in, and you can see that we have a line that is created by Desmos. So it actually does the graphing for you. So it's super helpful. Highly recommend that you guys use it, okay, to create your graph. And then you can use this graph then to answer the questions that you have. So at this point, don't consider any constraints. We haven't talked about those. And then last but not least, D, E, and F. So constraints could be the fact that you have to have whole numbers or books. Can't have half a book or a quarter of a book. And then E is just the constraints that are actually on the line itself. So when you graph it, you'll see those points on the graph itself. And then F is just looking at maximizing your options here. So I chose, let's see, 3 board books and 31 soft cover books, and that would give me exactly $20 when I plugged in those values. So yeah, so I don't want to spend too much time on each one, but I do want to kind of get you guys some information to help. Okay, so I'm going to scroll to the second problem here. This is an inequality. So this one's slightly different because we're going to have a shaded region on our graph, and we're going to have an inequality that represent that information here. So let's take a look. So 2 variable inequality. So we've got this birthday party, and it's $10.50 per child and $5.50 per adult. And we budgeted $300, and it's a $150 fee just to use the facility. So think if you went to like a trampoline place or something like that, you might have something like this, okay? So I defined the variables. I built an inequality based on that. For B, they tell you to plug in 10 children and 5 adults. Does that work? In this case, it does, because it's a little bit less. $282.50 is less than $300, so we can afford that. For part C, I created a graph. Now, again, I used Desmos to help me, and I would suggest that you do the same. Now, notice that your graph for the inequality is going to have a shaded region. So it's not just the values on your actual line, it's your shaded region inside. So any of those work as your values. So when we talk about constraints, okay, again, the only constraints that you have is that you can't have half of a child or a quarter of an adult. You have to have whole numbers for those values. So keep that in mind. Any solution, or it's going to be in the shaded region or on the line. So there's a lot of different options in this scenario. And in F, I built a scenario where you could have 13 children and 2 adults at the party and still fit under the maximum budget. So I came up with $296.50, which is less than $300. So that would work in our scenario. Okay, so that is question number 2. Let's take a look at question number 3. So let me scroll down to this one here. This one is a system of equations, and it is a fairly difficult one. So I want to go through a few things with this particular question here. So starting with the fact that we have a linear equation, and we also have a quadratic. Okay, so it says that 1/6 is a solution, so we can again plug that in for each one, for x and for y, and see if that works. And so when I did that, it worked for both, so it is a solution. Now, the second part is to solve the equations using substitution. This is where it gets a little bit challenging here. So the first thing that we want to do for part B is we want to solve for one of the variables. And so what I did was I solved for the y variable in the first equation. So that means I want to add x to both sides of my equation. So I'm going to get that y is equal to x plus 5. Okay. And then from there, I need to substitute that in for the y in the other equation. Okay. So my other equation is x minus 3 squared plus 2. And so I'm going to substitute that in. So I'm going to have x plus 5 on one side and in the other equation on the other. Okay. Now, once we get to this step, it gets a lot more complex because we need to expand x minus 3 squared. So we need to actually write that twice. X minus 3 times x minus 3. Okay, and don't forget about the plus 2. And then from here, we want to multiply these. We want to FOIL these together. So we need to use the FOIL. And so if we do that, we're going to get that x squared minus 6x plus 9 plus 2 is equal to x plus 5. Now, the next step is to get this x plus 5 over to the other side of the equation. So I'm going to subtract an x, and that's where I get the negative 7x. And I'm going to subtract a 5. Okay, and when I add 9 plus 2, I get 11. But if I subtract 5 from it, I get 6. So that's where that came from. Now I need to factor. So I need to find two numbers that add to give me my middle term and multiply to give me my last term. And that's going to be negative 1 and negative 6. All right, and then once I factor, then I need to solve. So I need to set these equal to 0. So I'm going to get that x is equal to 1 and x is equal to 6. Okay, so what I've done is I have solved using substitution. Now, in order to graph this, again, I would use Desmos and I would plug those two in because what you're going to get is a half quadratic and a half linear graph. Okay, so it's going to look something like this. And what you're going to notice is that there are 2 points of intersection. One is at 1, 6 in this case, and then the other one is at 6, 11. Okay, what you'll notice is that those two values represent the x values from when we use substitution. So x is 1 and x is 6. Okay, so just be aware of that. All right, and then the last question, could a system of equations that includes a linear and a quadratic have infinite number of solutions? The answer is absolutely not. Okay, the most solutions you could possibly have with those would be 2, and that's what we have in this scenario. Okay, And the reason being is a quadratic is curved and a linear is a straight line. So they will never match up. They will never look exactly the same. Okay. All right, let's move on to question 4. So question 4. Okay, so again, we've got a system of equations. We've got 2 equations that are not in the correct format. So first things first, we have to plug in the solution 0, 3. And in this case, 0, 3 works for the first one, but it does not work for the second one. So be aware of that. So is that a solution? The answer is no. Solve the systems using elimination. So what we need to do is we need to convert both of these equations into the same format. Okay, so what I did was I moved this 2/3 over to the other side of the equation up here. So I went ahead and I added 2/3 to bring it over here. Okay, and then what I did once I've done that is then I can multiply my equation by 2 so that I can get rid of the x's. So we want to get rid of one of the variables, whether it's the x or the y. And in this case, by multiplying by 2 and then subtracting these 2, I get rid of my x values. Okay. Now it just so happens in this case that I also get rid of my y values as well. So my x's and my y's cancel out. And what I have left is 10 minus 6, which in this case should be 4, not 16. So let me fix that. Okay. Because 0 is not equal to 4, okay, there is no solution for this particular system. They will never cross. Okay. So the next thing to think about is, could a system of linear equations ever have an infinite number of solutions? And the answer is absolutely yes, they can. What you're going to notice is that the 2 equations will be exactly the same. Okay, so if they're exactly the same, they have infinite number of solutions. Okay, and if so, could you tell by looking at their equations? Yeah, we're going to see the same slope, the same y-intercept. And how could you tell from a graph? Well, again, on the graph, those 2 lines will look exactly the same. Okay, they will intersect at every single possible point. All right, let's move on to question number 5 here. So this one, you're going to create your own system of inequalities. All right, so move that there. So I just came up with an example. You don't have to use this one. You can make your own. So I have x plus y is greater than 5, and 2x minus 5y is less than 10. Okay, so describe. So I plugged in a point. I took 2, 3. It worked for my first one, but it did not work for my second one, so it is not a solution. I graphed it, and again, you can use Desmos to help. Okay, what you're going to notice with a system of inequalities is that the overlapping region on your graph is the solution. Okay, so, and what I've done is I've shaded this overlapping region. So I use Desmos to help me with it, and I'd suggest the same. But this overlapping region is the actual solution for my inequality. Okay, and then last but not least, number 4, it says, could a system of linear inequalities ever have no solutions? What would this look like? And the answer is absolutely yes, you can have that. What you're going to have is you're going to have a graph that has no overlapping region on it. So you may have shaded regions, but there's never a place where those shaded regions overlap. And if that's the case, then you have no solutions. Okay, so guys, that's going to wrap up my presentation here. I hope this helps. Please submit this on notebook paper. Do not submit it on the worksheet that's included. If you want to use the worksheet that's included just to help you with the questions, that's great, but do it on a separate piece of paper, and please submit it using the pictures from your Chromebook.